Alright guys, so lesson 4.5 is called writing a function rule, and there's just 4 word problems here. This is just like a very brief overview. We're going to spend a lot of time in class doing a whole bunch of word problems, but we've pretty much done this before, so you should find that this lesson is pretty easy. Okay, so problem 1. It says, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is the function rule that represents this situation? So it's up to you guys. There's only 4 problems. It's up to you if you want to write down these word problems or not. We're going to do a whole page of them tomorrow, so if you just kind of want to watch them and try and, just figure out how you would write your own equation and then compare it to mine, that's fine. And if you want to write down the word problems, then just pause it and write down the word problems. Okay, so what we need to do here, it says, what is a function rule that represents this situation? So a function rule is the same as equation. So let's pick out our variables. Let's see. The outdoor temperature, so we definitely need to underline this. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. That's pretty much telling you your whole function. So write a function rule that represents a situation. So we need to define our variables. The 2 variables we have are temperature. So we'll do T equals temperature. And the number of chirps the cricket makes in 1 minute. So let's do N equals number of chirps per minute. Okay, those are the 2 variables being related. The temperature is changing based on the number of chirps made per minute. So what's a function rule that represents this situation? It says the outdoor temperature is. That's what you're always looking for. That's is means equals. So we have temperature equals about 40 degrees more than. So 40 plus 1/4 the number of chirps the cricket makes in 1 minute. Well, if N represents the number of chirps the cricket makes per minute, then we have 1/4 N. So the temperature equals 40 plus 1/4 N. Then if you wanted to figure out a specific temperature, you could plug in any variable, any value you wanted for N, like 5 minutes, 10 minutes, and that would tell you what the temperature was. Okay, problem 2 comes from a picture. So it says, a concert seating plan is shown below. Reserved seating is sold out. So that's this whole section right here. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. So this is general seating. Okay, write a function rule to represent the situation. And then we have to figure out what is the maximum possible total revenue. So our 2 variables here, we're going to need R is going to be the revenue. And that's just like the total profit that they make. That's all revenue is. And then we need another variable. So if you think about it, okay, how much money they're going to make is going to be, well, this is already sold out. So they've already made, let's see, there's 10 rows, there's 12 seats per row, and each seat costs $25. So they've already made money on this whole entire section. 10 times 12 times 25 is 3,000. Okay, so as far as their revenue goes, they've already made $3,000 because that whole entire section is filled out. All 10 rows, all 12 seats in each row, and then each seat sold for $25. Okay, now we have general seating, which is $10 per seat. So we're going to take the 3,000 plus $10, and we need some kind of other variable. Maybe, well, we can't use R. We can just use N. And N can represent the number of tickets sold in general seating, because we already did the reserved seating. Okay, so that would be your function rule. The revenue is going to be $3,000 plus they're going to make $10 on every single ticket they sell in general seating. Okay, so that's our function rule. Now it says what's the maximum possible total revenue? Well, it's going to be if we completely sell out of general seating. So what's the biggest number you could put in for N? What's the biggest number of tickets you could sell in general seating? Well, there's 30 rows, and there's 16 seats per row. So 30 times 16 equals 480. Okay, so if we sell out in general seating, we would sell 480 tickets. So that would be 3,000 plus $10 for each ticket times 480, and that is a total of 7,800. So if they sell out the whole stadium, the maximum possible revenue they would make would be $7,800. Okay, problem number 3, let's see. We have a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost of N days of boarding plus a bath. How much does a 10-day stay cost? So they're already telling you one variable. N is going to represent the number of days. And you need another variable. Write a function rule for the total cost. So I'm just going to say C is going to represent total cost. Okay, so let's see. The cost is going to be equal to, it charges $15 per day. So you're going to have 15, and then if N is the number of days, well, it's going to be $15 for each day, so 15N, and then plus the bath. And the bath is only a one-time thing, so it doesn't matter how many days they stay. They just pay $12 one time to get a bath. So that's your function rule. And then this part right here, how much does a 10-day stay cost? Well, if N is the number of days, we just plug in 10 for N. So we have 15 times 10 is 150 plus 12 is equal to $162. The cost would be $162 for your dog to stay for 10 days. Okay, and last problem. This is in those last 3, those were all linear. This is actually the first function rule that's nonlinear. So it says write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when the width is 9 feet? So anytime I can draw a picture, I draw a picture. So this is the length, and this is the width. It really doesn't matter which one you label. Technically, actually, I'm going to switch those because I like to keep things consistent. I always say the length is the longer one and the width is the shorter, but it doesn't matter at all. Okay, so write a function rule for the area of a rectangle. So you know that area is length times width. Okay, but this is a specific rectangle whose length is 5 more than its width. So instead of this variable being L, we're going to replace the L because it says right here the length is, so L equals 5 more than the width. So we're going to take that 5 plus W and we're going to write it in place of the length, because the length is 5 more than its width. So as far as our formula, in place of L, we're going to have 5 plus W, and then we're going to multiply that by W. Okay, and now we have to use the distributive property. So W times 5 would be 5W, and then W times W, we've only done a little bit of exponents, but when you multiply, you have to add the exponents, and those both have an exponent of 1, so that would be W squared. So our formula would be A equals 5W plus W squared. And then it says, what is the area of the rectangle when the width is 9 feet? So we're going to plug in 9 for the width. So 5 times 9 plus 9 squared. So we have 45 plus 81 equals 126. And let's see, and then this is in feet, so our area would be 126 feet. Okay, and we're going to do a whole bunch more of these in class, so that was just a little introduction. Now, go ahead and try the lesson check. It's on page 264. Okay, there's 6 problems there. First 4 wants you to try and write an equation, and then the 5, 6, and 7 is just kind of about vocabulary and looking at problems. And those are the problems that we'll start with tomorrow. Okay?